Generative AI, often referred to as GenAI, is one of the most significant shifts we have seen in modern computing over the last decade. Unlike traditional AI systems that focus mainly on classification, prediction, or decision-making, generative AI is designed to create new content. This content can include text, images, code, audio, and even video, making GenAI far more flexible and expressive than earlier AI approaches. What makes GenAI especially powerful is how humans interact with it. Instead of using rigid interfaces, structured queries, or predefined rules, users can interact using natural language. You can ask questions, describe tasks in plain English, or give high-level instructions, and the system generates meaningful, context-aware responses. This natural interaction model is fundamentally changing how people use software, lowering the barrier between humans and complex systems. To understand why GenAI is different, it helps to compare it with traditional AI approaches. Traditional AI systems are usually trained for specific tasks, such as predicting outcomes, classifying data, or detecting anomalies. Their outputs are typically limited to predefined labels, categories, or numeric values. Generative AI, on the other hand, produces entirely new outputs that were not explicitly present in the training data, such as original text, summaries, or code snippets. At the heart of most GenAI systems are large language models, commonly known as LLMs. These models are trained on massive volumes of text data, allowing them to learn the structure, patterns, and relationships within language. Rather than memorizing facts, LLMs learn how language works statistically and generate responses by predicting the next token based on context. This is why they can adapt to many different tasks without being explicitly programmed for each one. Training these models is an extremely expensive and resource-intensive process. It requires huge datasets, specialized hardware like GPUs, and significant computational power over long periods of time. Once training is complete, the model enters the inference phase, which is when it generates responses to user inputs. Inference is what happens when you interact with a chatbot, a coding assistant, or any GenAI-powered application. GenAI is already being used across a wide range of real-world applications. These include chatbots and virtual assistants, code generation tools, document summarization systems, search experiences, and content creation platforms. Many modern software products now embed GenAI capabilities to improve productivity, automate workflows, and enhance user experience. However, GenAI models also have important limitations. They are trained on static datasets and do not automatically know about recent events, private data, or organization-specific knowledge. They can also generate incorrect or misleading information, a behavior commonly referred to as hallucination. Because of this, GenAI systems cannot be used safely in production without additional architectural components. This is where Retrieval Augmented Generation, or RAG, comes into play. RAG combines GenAI models with external data sources such as databases, documents, or knowledge bases. Before generating a response, the system retrieves relevant information and provides it as context to the model. This grounding step significantly improves accuracy, relevance, and trustworthiness. In real-world production systems, GenAI is rarely used in isolation. It is typically integrated with APIs, vector databases, retrieval pipelines, monitoring systems, and safety guardrails. Designing these systems requires careful consideration of performance, cost, security, and reliability. A well-architected GenAI system is as much about system design as it is about the model itself. As GenAI continues to evolve, understanding these foundational concepts becomes increasingly important. Before diving into advanced topics like embeddings, vector databases, and HNSW, it is essential to understand what GenAI is and how it fits into modern software architectures. Key takeaways. Generative AI is a class of AI systems that generate new content rather than simply making predictions. It is powered by large language models and relies on probabilistic language understanding. To work reliably in production, GenAI must be combined with proper architecture, retrieval mechanisms, and safeguards. In the next video, we'll dive deeper into retrieval augmented generation and explain how RAG improves accuracy and reliability in GenAI systems. If you found this video helpful, then like and subscribe to the channel for more GenAI deep dives. Thanks for watching.